Okay, so let's say I give you a problem. Let me make this a little larger. So let's say we have, the problem will be here in black. Let's say I give you, let's say f of x, or the function is equal to x to the fourth plus 2x to the third minus 7x squared minus 8x plus 12. And let's say there is a root at x equals -3. So first thing, I know immediately that there is a factor at x plus 3. And then I just need to go use synthetic division to take that factor out of this. So let's do that. So this will be a -3 because I'm going to put the root on the outside. 1, 2, -7, -8, 12. And then we're just going to do synthetic division just like always. So the 1 will come down. -3 times 1 is -3. This would be -1, +3, -4, +12. This would be 4. This would be -12. So this would be 0. If you did this correctly, all factors give a remainder of 0. Okay. So if you do not get a remainder of 0 here, then this is not a factor. Okay. I told you it was, so we know we should get 0 here, but the 0 remainder indicates that it evenly divides in.
Would we have a question on like a quiz or test, or the test where we have to figure out if it's going to be a factor or not?
Yes. I'm going to show you some of those in a little bit. Okay. So there are kind of 2 steps to what we're doing today. One of these where I give you a root, so you know where to start, and one of them where I don't give you a root, and you have to figure out where to start. Right. Okay, so let's write the remaining bit here. So we started with degree 4, so this will drop down to degree 3, so this will be minus x squared minus 4x plus 4. Now don't forget, this is what's left, but if we are factoring, I can't forget that I just factored out an x plus 3. So now we're here. Right, so I've got one thing factored out. And now I'm going to try to factor this with my normal factoring methods. Now, it looks like a factor by grouping is the best option to start with because there are 4 terms. So we'll start there. Let's see if we can factor this by grouping. That'd be x squared, and then left behind would be x minus 1. Here I'll factor out a minus 4, and then I'll be left again with x minus 1. So it looks like that's going to work. So just continuing, we'll bring that first factor on down, and then we'll complete the factor by grouping. So this is an old skill. This is just the plain old factoring with 4 terms. Is this completely factored yet? No, we got to factor the difference of squares. That's the easiest way to lose a point on your test on Friday, is to miss that this is not all the way done yet. 2x minus 2x plus 2. You'll get the roots right, but you won't get the factored form right. So here's your factored form. And let's write the roots. The roots are at -3, +1, +2, and -2. I'm just setting each factor equal to 0. Now don't forget, we can always go back and be like, do I have all the roots? Did I get them all? This is a 4th degree polynomial. I have 4 roots, so I'm good there. Yes, ma'am.
Would the y-intercept be 12?
So the y-intercept here, the y-intercept for this, I'm going to tell you a shortcut. The y-intercept here is 0, 12. So this always works, that whatever the constant is out here that's not multiplied by x, that's going to be your intercept. Well, I mean, and you can take the long way around, right? You can plug in zeros everywhere, but you'll see that this is the only one that doesn't drop out because it doesn't turn to a 0. The y-intercept is that. The only other information we really need to graph this thing is that it is an even function, because the degree is an even number, and the leading coefficient is positive. So with this information, I can graph, I can sketch the function. So let's go ahead and do that. That's junky, but it's okay. It's cool. It's fine. So I have a y-intercept at 0, 12. So I'll just say, that's 12. I've got roots at, I got one at -2. I got one at -3. I've got one at +1. I got one at +2. In behavior, leading coefficient is positive, so I know it goes up on the right. Because it's an even function, I know it does the same identical thing on the left. Then we need, these are all going to be crosses, right? They're singles. Cross, 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 cross. We'll start up here. That one's going to cross. That's going to cross. It's going to pass through the intercept. We're going to cross again. We're going to cross again. In behavior checks out, passes through everything exactly like it's supposed to, so I feel pretty confident that I'm good with my sketch.
On the test, will we have to sketch some out?
All of them. There'll be 4 problems on the paper part of the test. So the first part of the test is going to be where I give you the dotted line in Desmos, and you have to make the function sit on top of it. The second part of the test on paper is going to be, I'm going to just give you a problem like this. And I'm going to say, show me the factored form, the roots, the y-intercept, the in behavior, and sketch the graph.
Will we have to draw the x and y axis and everything?
No, I'll give you an axis. I'll give you an axis on this. There will be some where I don't give you a root though. We'll do that later. Let's let you try one example. So let's say f of x is equal to x cubed minus 28x minus 48, and let's say there is a root at x equals 6. So you need the factored form, the roots, and sketch the graph. And so your first step is going to be factor using synthetic. Then factor some more. And solve for x.
When we do the synthetic division, will it always be a negative on the outside of the little?
It is like, because look, the root is at +6 now, so the +6 goes on the outside. I'm going to give you a little bit. And then we're going to look at it together, and I'm going to do it. I want you to make sure you're paying attention to whatever you did diverged from what I did. All right. Only done. Oh, yeah. All right. Let's try one where I don't. Let's try one where I don't give you a root, and let me teach you how to do that.
I'm good.
You're good. So there will this will be the other type of question that you'll see, where I'll be like, factor it, solve it, and sketch it, right?
Okay.
So the issue here is that you don't have a root. It is definitely a problem, right? Because where do you even start? I mean, one option is just to try every number until you get one. But we're going to try to narrow that down a little. So my suggestion to you at first is that you don't try to write what I'm writing. Like, write it down the second time I go through it, because otherwise you're going to like miss what I'm saying because you're trying to write. Okay. So the first thing I'm going to do is I'm going to look at this number and this number. And so I'm going to come over and I'm going to write, let me get some color so you can follow what I'm doing. That's this two and that's this two. This is P and Q. So I'm going to write all of the factors of this number. I've got 1 and 2, right? Then I'm going to write all the factors of this number, 1 and 2. And then I'm going to write every possible combination of plus or minus P divided by Q. So let's do that. Let's do this one first. Let's do plus or minus 1 divided by 1 plus or minus 2 divided by 1. And we're going to do plus or minus 2 divided by, that's confusing, 1 divided by 2 plus or minus 2 divided by 2. Okay. And so these are called PRZs, or also known as the possible rational zeros. So this shortens the list of things I need to try. So let's go over and actually write the PRZ list. So here's the PRZ list. And I'm going to go back and I'm going to show you how I got it. 1 over 1 simplifies to 1. 2 over 1 simplifies to 2. 1 over 2 is 1/2. And 2 over 2 is what? 1. We've already got 1 in the list, so I'm not interested. So these are the ones I'm going to try. Okay. So I'm going to try all of these roots. I'm going to try positive 1. If that doesn't work, I'm going to try negative 1. If that doesn't work, I'm going to try positive 2. If that doesn't work, I'm going to try negative 2. If that doesn't work, I'm going to try positive 1/2, and so on and so forth. But that is how you get your root list. So let me show you how I got this. Okay. I looked at the last number. That is I found all of the factors of 2. The only possibility is 1 times 2. There's no other way to get 2. I'm going to do another one of these. And then I took the blue number, which is the leading coefficient, and I found all the factors of that number. There are no other possibilities other than 1 and 2. So then I'm gonna write every possible combination of these numbers over these numbers. So I'm just gonna take both of these, plus or minus 1 and plus or minus 2, and put that first Q number underneath both of them. Then I'm gonna take the second P. So we're gonna take these two numbers again, 1 and 2, and do it by the second Q. So I did 1 and 2 divided by 1, and then I did 1 and 2 divided by 2. And then I simplified those fractions to get the possibilities for the roots. Let's try the first one. We'll do it again. We'll do it again. All possibilities of P over Q. So I don't know, let's just start with 1. Start with positive 1. Let's see if it works. This would be 2, this would be 1, this would be negative 5, this would be 2. How do I know if that's a root or not? Get a remainder of what? 0. Very good. So this would be 2, 1 plus 2 is 3, 1 times 3 is 3, this is negative 2, 1 times negative 2 is negative 2, so we get 0. So is 1 a root? Yes, so 1 is a root, and look, now we're back at the start, we know what to do now. So that means that x minus 1 is a factor. So this 0, so let's write it. X minus 1, I'm gonna go all the way back through. So this will be, what do we start out with? What was the degree? I can't remember. 3. So this will be 2x squared plus 3x minus 2. Remember, after we divide out the first root, I'm going to assess what's left to see if I can factor it. Looks like a trinomial factor, so let's try it. Negative 4 sums to 3. That's 1 times 4 with the 1 negative, so that'll work. So let's factor this second piece here. It's going to have to be a factor by grouping, so I'm going to bracket it off so I can keep it separated. So this will be 2x squared minus x plus 4x minus 2. And then I'm going to factor that by grouping. That's an old skill. So this would be x, and then you'll have 2x minus 1. And the common factor here would be 2, and so that'll be 2x minus 1. So it looks like factoring by grouping does work in this case. So here's the first factor, here's the second factor, and here's the third factor. Can't factor this anymore, so we got our factored form. And now we can also write our roots. 1, 1/2, and negative 2. Notice that 1/2 we suspected would be there is there. You know, we had 1/2 in our list up here, right? Yes.
So does that mean like the negative 2 could have worked too and the positive 1?
Correct. If you had chosen to start with either of those other two, you would have been able to proceed in the factoring it. All right, so just finishing it up here, let's do leading coefficient. Leading coefficient is positive, it is odd. Y-intercept is, something. Looks like the y-intercept is 0, 2. And we should be able to take all of just this stuff. Yeah.
Where did you get the negative 4? The multiply negative 4?
2 times negative 2.
Do you do that every time?
Yep, every time.
So that's what you count.
All right, so y-intercept. That's a good question. All right, so let's just sketch this little junky looking graph here. Yeehaw. Let's start here. Y-intercept is at 2. Roots are at 1, negative 2, and 1/2. It's positive on the leading coefficient, so this goes up. It's odd, so this goes down. These are all crosses. So we're gonna go up through here. We're gonna go down through there, and then we're gonna go back up like that. All right, and I'm gonna go back and I'm gonna walk you through the whole process, okay? And we're gonna do another one before I let you practice on your own. Let's look at the whole problem all at the same time. I know. Yeah. It's gonna be good. Is that too small or can we see that? We can see it, we can see it, we can see it. All right, cool. All right, so the first thing I did is I looked at this problem and I recognized I could not factor it by grouping because if you try, it's not gonna work.
I'm trying to get this last one on paper.
The next thing I'm gonna do is I'm gonna look at the last number and I'm gonna find all of the factors of that number. Look at the first number and find all the factors of that number, and then I'm gonna write every possible combination of the factors of this over the factors of this. Look here. So I just took 1 and 2 and I used 1 as a denominator first. Then I took 1 and 2 and used the 2 as the denominator. Simplified all my fractions and got the actual final list of potentials for the things that I could factor out. Luckily, I just started with positive 1, it just happened to work. So 1 is a root, and x minus 1 is a factor. I know this is a root because I had a remainder of 0 when I divided. From there, I rewrote the factor and what remains, right? What was left over. I noticed that at this point, I could go ahead and factor using the normal factoring techniques. This is a trinomial factor right here. 2 times -2 is -4, so I'm looking for two numbers whose product is -4 and whose sum is 3. 1 and 4 fit, the one negative, that'll give me that. Then I factored by grouping. I ended up with this as my factored one. Set each factor equal to 0, I've got the roots. Going back and double checking myself, this is a 3rd degree polynomial, so I should have 3 roots. And I did 1, 2, 3. After that, I'm ready to go graph it. And in order to graph it, I've got to have the y-intercept. I plugged in zeros everywhere there's an x. Or I used the shortcut that tells me that this number, if it doesn't have an x, is going to be a y-intercept. I then looked at the leading coefficient. It is positive. The degree of the function is an odd number. That's the 3. The leading coefficient sign determines whether the right-hand side of the graph goes up or down. Positive goes up. The fact that it is odd means that the left-hand side does something different. If it was even, it would do the same. I know that all of these are crosses and not touches because there are no multiplicities here. These are all single roots. There's no double value. It would indicate it bounces off the axis. And then this one goes down, so I started down here, cross, y-intercept, cross, cross, and end up on the right-hand side. Let's do another one. Let's do another one for you, practice. There's only one, I think, tomorrow or Friday, one maybe two that I do not give you the root. Okay. But you see now why I said, like, if you can't factor it, I mean, how are you going to do the rest? If you can't do synthetic division, how are you going to do the rest? Really, the only new skill today is understanding that the synthetic division gives you a factor and to find the possible roots if you don't know one. That's the only new skill. Everything else is just piled on top of everything we've already learned. I know it's tough. I try to at least be honest with you when it's going to be and tell you ahead of time. You know, it just is what it is. So we got this. We can do it. Let's do another one. Let's do 3x to the third minus 19x squared. Blah, blah, where'd it go? Plus 33x. Minus 9. So again, I try to guide you through the way I think about working through a problem like this so that when you are doing it, you can maybe prompt yourself with the same questions. Because I look at it and I'm like, is factoring by grouping going to work? No, 3 and 19 don't have any common factors. 33 and 9 have a 3, but it's not going to work. And if you work it out and see that it doesn't work, then you know it doesn't. So, if you can't see it right off the bat, just try it. If it doesn't work, then you know it doesn't work. So in order to fix this, I've got to find the PRZs. So I'm looking for factors of 9 and all factors of 3. This number and this one. So the factors of 9, 1 and 9, and 3 and 3. The factors of 3 are just 1 and 3. Everybody with me so far? I'm just finding all of the numbers that multiply together to give me those two numbers. And so now I'm going to look, again, remember this is P and this is Q, and I'm going to try to make all the fractions that are possible with plus or minus P divided by Q. So I'm going to say, okay, plus or minus 1, maybe it's easier to see this way, plus or minus 3, plus or minus 9. That's all these numbers. And then I got to put a Q on bottom. So let's just do the first one. Divided by 1, divided by 1, divided by 1. Are you with me so far? I used all of these on top, and then I just used the 1 as the denominator. Let's go back and use all of the P's again, plus or minus 1, plus or minus 3, plus or minus 9. And now let's use the 3 on bottom instead of 1. That'll give me all possible combinations. Let me see if I can guide you with some color here. So that's just me putting this down here every single time. And this one is me putting that down there every single time. And these numbers are repeated. All right, so why didn't I put 3 twice?
Because it's already there.
It's like already there. It's the same number. I don't need it again. All right. So now let's like consolidate it and write everything simplified. 1 over 1 is 1. 3 over 1 is just, 3. 9 over 1 is 9. 1 over 3, well, that doesn't simplify at all, so that's 1 over 3. 3 over 3 is 1. We've already got that up there. 9 over 3 is 3. That's already up there as well, so I'm not going to write it again. So these are my possible rational zeros. These are the ones I'm going to try. Let's try positive 1. Let's try positive 1 and see if it works. Oh, this will be 3, negative 19, positive 33, and negative 9. 3 times 1 is 3. That's negative 16. Negative 16. I don't know what that is. 33 minus 16. 33 minus 16. That's 17. 1 times 17 is 17. I don't know what that is, but it ain't 0. So this is not 0, so it's not a root. So 1 is not a root because I divided by this potential root out here. It didn't work. Now I'm going to try negative 1. I systematically move through these because as soon as you skip 1, that's going to be it. Here we go. Try again. 3. Negative 3, that's going to be negative 22. This will be positive 22. I'm pretty sure this is not going to work, right? I mean, we can see it through. This will be 55, negative 55. Who knows what that is? Who cares? That doesn't work. So this is not, what is that?
Oh, shoot.
That's negative 64. Definitely not 0. Negative 1 is not a root. I have to keep going until I find one. Okay. What's the next in the list?
Plus or minus 3.
Yep, so let's start with positive. I like positive 3. Let's try 3. 3, negative 19, 33, negative 9. 3, that's 9, that's negative 10, that's negative 30, that's 3, that's 9, that's 0. Looks like 3 is a root. Yes. So that means that 3 is a root. So x minus 3 is a factor. Now we're cooking with grease. So now we can do some things. So this is a factor. This is what is remaining after I remove this factor. So this started out as what? What was the degree when we started? 3? Third degree polynomial? Yeah? Okay, thanks. Sometimes you got to go back up and look because you're doing so many things you forget what you're doing. So then we're going to rewrite it. At this step, what's left, I'm going to try to factor that with the factoring methods I'm already familiar with so I don't have to do that PRZ process again, right? We're looking for two numbers that multiply to positive 9 and add to negative 10. It's like negative 1 and negative 9 will work, right? Negative 1 times negative 9 is 9. Add these together. So I gotta set this up as a factor by grouping. So this will be minus x minus 9x plus 3. Split that middle term according to these special numbers, and then, I can factor by grouping. This will be x, so I'll be left with 3x minus 1. I'm going to pull out a negative 3 here, so I'm left with 3x minus 1. So the first factor is x minus 3. Second factor, 3x minus 1. Third factor, x minus 3. I can't do anything else with this. They're all as factored as they're going to get, so that's my factored form. The roots are found by setting each factor equal to 0. 1 over 3 and 3. Look, I have a multiplicity here. So that's actually going to be 3 multiplicity 2 and 1/3. Or I will also accept as the factored form x minus 3 squared. 3x minus 1. See, because there are 2x minus 3's. Okay. Then I need the LC, which is going to be, go back up here. LC is positive, leading coefficient. This is an odd function. The y-intercept, I don't even remember. Let me go look. Negative 9. There it is. And with this information, I can do everything else I need to do. So I'm going to do that. So remember, these are the only things I need. Y-intercept is at negative 9. I got a touch at 2. And I got a root at 1/3 or whatever.
We had a touch at 3.
Huh?
We had a touch at 3.
Yeah. Thank you. You're right. The multiplicities too. Let's look at it. I'm trying to figure out how it's going to work. Yeah, LC is positive, so that goes up and this goes down. Oh yeah, I see it. Okay. Yeah. I'm gonna start. It's easier to start on this side this time. So it's gonna bounce. Let me do that in black. Yeah, so it'll touch here and go just like that because it crosses at 1/3. In behavior matches, I was able to pass through the y-intercept. I bounced here because of the multiplicity 2. I crossed over at 1/3. Let me zoom out, go over it with you, and then we're going to practice. These take a minute. Blah, 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 blah. Okay, let me go over it with you. Okay, so I looked at this. And your instructions were to show me the factored form, the roots, and the graph I'm like, oh, it's got 4 terms, but wait, factored by grouping does not work. So my only other option is use synthetic division. In order to get the synthetic division, I've got to have somewhere to start. Got nowhere to start, right? You just use every number that exists because that's going to get all quick. So I'm going to pull the last number, find all its factors. I'm going to pull the first number, find all its factors. I'm going to write all these numbers with the denominator of 1. I'm going to write all these numbers again with the denominator of 3. That's where I get these. I'm going to simplify the fractions so I can eliminate any that are duplicates, right? This is a hidden duplicate. 9/3 is just 3. So then I'm going to start systematically working my way through these roots. The first one up is +1. Synthetic division told me this is not a factor. The 0 is not the remainder. So I move on to -1. Again, not a factor. And I tried +3, which was the next in line. Found that the 0 remainder told me it is a root. So x minus 3 is a factor. Wrote this because that's what's remaining, and I tried a normal factoring method. It's going to be a trinomial, so we'll factor it like this. I was able to do that. Factored it by grouping, just as is standard, and then found my roots by setting equal to 0. 3 is a multiplicity of 2 because there are 2 of them. Leading coefficient is positive, so the right side goes up. It's odd, so the left side does something different. Odd, different. Y-intercept, -9. This is a touch again because of the multiplicity 2. I know this has got to go up, so I'll start over here. I'll bounce off 3, pass through 1/3, and then go through -9 as the intercept.
I thought you said you couldn't like balance without like a.
I didn't. I only touch the x-axis where the roots are.
No, like you said. Never mind.
Do you understand what you're asking? Okay. Okay. You can touch this. That's the intercept. You can do that. But, that's why I have you find that. Because, if you're backwards, if you had tried to do this backwards and you couldn't cross through the intercept without crossing something else, you messed up. So all these things kind of lock you in. And if you missed your touch right here, your end behavior would have been up over here. So you immediately know something's wrong because if it's odd, it should be going in different directions. But these touches and crosses won't let you do it wrong. Okay. All right. I've got some problems up for you in classroom. I'm not going to give you roots on any of them because if you can find the PRZs and find the roots yourself, then you're good. What's a way you can check your answer on a problem like this without a key? Desmos, right? Like watch, I'll check this one with you. Let me go put this function in there. Let's put that problem in and show you how to check it. This was 3x to the third. I mean, I'm going to let you check it with a key tomorrow, but for now, you should be able to easily do that by making the connection between the roots and the graph. Plus 33x minus 9. Oh, there it is. Let's see, I got a root, then I got an intercept down here. So all that matches. So I know I did it right. If the roots match, you're good.